Good morning. It's my great pleasure to welcome Secretary of Energy Jennifer Granholm. I've had the privilege to work closely with her and see firsthand the leadership in fostering an ecosystem of collaboration and innovation throughout the Department of Energy. This is especially true of her support of ARPA-E. Her guidance has accelerated America's transition to clean energy, and we are thrilled to have her with us to share her insights. Please join me in welcoming Secretary Granholm.
Great. Thank you, Evelyn. Evelyn, of course, was once an ARPA-E awardee herself, and thank you so much for your team bringing us together today, and really, for the first time, an ARPA-E Summit hosted in Texas. And I just have to say to the entire ARPA-E team, some of whom have been here since the very beginning, you are the sentinels of science, the drivers of discovery. So to the ARPA-E team, thank you so much for your service. So in September of 1962, President John F. Kennedy visited Texas to make his case that America should go to the moon. And at stake, of course, was our nation's courage, really, to do big things. Our reputation as the world's great engine of innovation, our status as a leader among nations. And President Kennedy said these words. He said, "The challenge is one that we are willing to accept, one that we are unwilling to postpone, and one which we intend to win." Today, we are neck and neck with our competitors in another race, which is, of course, to unlock and unleash the power of clean energy. On the line is this $23 trillion economy globally, larger, this energy sector, larger than the GDP of any country outside of the US. We're competing for the world's most sought-after jobs, manufacturing jobs, by the way, that can be the beating heart of America's heartland for the next century. We're competing for those. We're competing for freedom over our future, a future where we are not going to be relying upon others to power our homes, our transportation, our business, our schools. On the line is our pride. It's our mojo. But that's not all, because this is also a race, as you all know, to save our shared home, this planet. The people in this room are America's best hope. The technologies that you create will decide whether we win that race, but no pressure. It's said that the famed French Marshal Lyautey once asked his gardener to plant him a tree. And skeptical, the gardener replied, "Well, it won't bear fruit for 100 years. And Lyautey said, "In that case, plant it this afternoon." Lucky for us, many of you planted your trees long ago. And now there's fruit. So I want to give you some examples of this to inspire the ones who are just now planting. So in 2012, SELA won its first ARPA-E award to experiment with nanotechnologies that power lithium-ion batteries. And 12 years later, they're building a 600,000 square foot manufacturing plant to do just that. I visited their construction site in Moses Lake, Washington. They're going to be producing enough silicon anode material for 140,000 EVs. They'll create over 400 jobs in this small community. That community is so grateful. In 2014, LanzaTech used its first ARPA-E award to help transform carbon waste into cleaner fuels and chemicals. And now, 10 years later, they're planning to turn CO2 into sustainable ethylene on a commercial scale with help from a $200 million DOE award. Or take heirloom carbon. They were awarded $500,000 from ARPA-E to alter the chemical makeup of limestone so that it can absorb carbon from the air. And in November, I visited them in Tracy, California, the first commercial direct air capture facility in the United States. And now, Heirloom has set a goal of removing 1 billion tons of CO2 from the atmosphere by 2035. Dozens of companies that started with small grants from ARPA-E to chase far-out ideas are now these large industrial players that are transforming our energy landscape. The audacity of the scientists, the grit of the entrepreneurs, the courage of the investors. You have redefined our conceptions of what's possible in energy, writing new recipes for low-carbon cement, mobilizing membrane technologies to cut greenhouse gases at pulp and paper mills, inventing the very industry for low-cost and continuous methane detection and mitigation. The Department of Energy, we are so proud to be your partner. We're determined to take leaps of faith in your ideas. And now, with unprecedented funding from President Biden's agenda, Invest in America agenda for large-scale demonstrations and debt financing, we're ready to shepherd your projects through the valleys of death, or I guess I'm supposed to say mountains of opportunity, to the promised land of commercialization. And, I mean, to be honest, not all of them are going to make it, right? But that's all right, because with ARPA-E, we are not swinging for singles and doubles. We're going for grand slams. The worst thing that ARPA-E can be is timid. If we're led by fear of failure, if we fund what everybody else is funding, if we steer scientists into narrow lanes, we're never going to make that next big breakthrough. We're never going to win the clean energy race. We'll never tackle the climate crisis. We've proven the ARPA-E concept, that ideas can turn into industries. And now we need to mash the accelerator. So my great hope is that the future of ARPA-E will be as bold as its past. Let's try revolutionizing the grid with robotic worm tunneling or quantum radio frequency sensing. Let's try building modular data centers for AI computing that slash the power needed for cooling servers. Let's try catalyzing fusion reactions with subatomic particles that produce energy at even lower temperatures, paving the way for the private sector to make big bets, bringing the most innovative businesses to market, embracing failure as the first step towards success. That's the American way. So when an ARPA-E awardee succeeds, the next great American company is born, and we move a step closer toward our ambitious climate goals, and the pride of American innovation reverberates in small towns and in big cities across the land, all reinforcing what we have come to know about ourselves, which is that in this country, we're unafraid to dream. We are unwilling to be surpassed. We're always ready to step up and save the planet for the world. President Kennedy believed that, this quote, as we grapple with problems without precedent in human history, the challenge may be our salvation. I have every confidence it will be. Thank you all so much, dreamers and doers.
Ladies and gentlemen, please welcome the Honorable Jennifer M. Granholm, U.S. Secretary of Energy, U.S. Department of Energy. Michelle Chao, Co-founder and Chief Operating Officer, Phoenix Tailings. Tim Latimer, Co-founder and Chief Executive Officer, Fervo Energy. And Ezana Mekonnen, Chief Technology Officer, Imagen Energy.
Well, thank you, Ezana, Tim, Michelle, for joining us in this conversation with Secretary Granholm and myself. It's really great to have you here. You're all ARPA-E awardees. So let's talk about your tech. Ezana, share with us, what is your tech about?
Thank you. It's an honor to be here. We are focused on making a compact power module for a DC fast charger.
Can you elaborate a little bit further?
Elevator pitches, please.
We started our company with the goal of miniaturizing power converter, and we were fortunate to be part of a circuit program that pushed that goal even to a higher place with efficiency and power density target. And we did that starting from 2018 to 2021. But the great thing about being part of a circuit program, an ARPA-E cohort, is we also have to focus on tech to market, make sure that technology doesn't sit on a shelf. And we did that with our pivot to EV charging and with the partnership that we were successful to capture for our commercialization.
That's great. Thanks for that brief overview. Tim, how about Fervo Energy?
Yeah, so Fervo Energy, we're an enhanced geothermal systems developer. People have tried enhanced geothermal systems for a long time. There's been great research supported by the DOE since the 1970s on the topic, actually. But we've been able to bring about a breakthrough in the technology by being the first to incorporate horizontal drilling into enhanced geothermal systems. And so actually, last year we brought online our first pilot project. Most enhanced geothermal systems tests had used vertical wells for the last 50 years. And we actually, at a project site in northern Nevada, drilled a pair of deep horizontal wells, so 8,000 feet down, 3,000 feet over through solid granite, an injection well, and a production well pair. And we brought that project online in November of last year, and it's the first commercially successful enhanced geothermal system test ever. So a 3-megawatt demonstration pilot, directly supported in a couple different instances by ARPA-E, which I'll be happy to talk about and very grateful for. And we're now scaling up that technology quite rapidly. So we're going through about a 100x scale up in growth right now. We're doing a project in Southwest Utah that will be 400 megawatts when we complete it in 2028. And we think that geothermal has a huge role to play in the energy mix, and with the technology innovations that we've brought forward, supported by ARPA-E, it finally has the cost structure to really scale and meet its full potential.
It's very exciting. And Michelle, how about Phoenix Tailings?
Absolutely. I want to start by saying every electric vehicle, every wind turbine, hell, even every phone in this room works because of the critical materials inside of it. In particular, rare earth metals is one of the challenges that we're addressing. For every ton of rare earth metal produced, about 2,000 tons of toxic waste is generated. That pollutes the environment and creates a huge health hazard for the local workers and the communities. We're addressing that challenge. At Phoenix Tailings, we are building the world's first fully clean mining and refining company, producing these critical materials without any hazardous waste and with no emissions. So we've developed a clean process and chemistry that addresses this problem. We've taken it from the lab to the pilot, and we are now one of the largest commercial producing rare earth metal refining companies in the United States.
Okay, wait, now, Michelle, let me just ask you, because it's my understanding that you all started in someone's backyard and you now have a manufacturing facility. How did you make this jump so quickly? And did you make it quickly?
Yes, we did start in the backyard. My co-founder and CTO, Tomas, which I met at MIT, we saw this challenge in the world. We said, hey, we need to make metal sustainably. This can't be done the way it is right now. So quite literally, we were in Cambridge, Massachusetts, and we got our hands on a little bit of that waste material and made that first bit of rare earth concentrate and iron metals out of tailings waste. That was about 5 years ago. We've definitely grown a lot more since then. We have a real proper lab, and that's taken a lot of time, energy, and a full team of people and the support of folks like ARPA-E and DOE to help us get to where we are today. We still have a lot more to go, but it's definitely been a challenge, and we see a lot of potential moving forward.
Yeah, we're really appreciative of the fact that you're solving for a problem that we have, which is to make sure that we are able to get these critical minerals sourced in the United States, and it's very exciting.
So Ezana, it's an exciting journey for you. In 2017, you first got your first ARPA-E award, and you just got acquired by ABB. So how did it happen? Woohoo!
Yeah, it was a long journey. I think typically for a hardware company, it's very hard to raise funding because hardware is very hard to scale as compared to software. And we were very thankful that we had an ARPA-E award for us to put together a minimum viable product that was compelling for a company like ABB that's big, and they were able to look closely and realize it's strategic for them in terms of where they want to take their technology. So yeah, the acquisition happened last year, and also we have a partnership to take what we're working on and get it through industrial maturity. And with the infrastructure that they have, they'll be able to take what we're developed and then deploy it in a mass scale. So,
can I jump in, Ezana? Because when people think about charging, they think about charging stations that you drive up to and you plug in. You say yours is more modular. Can you describe what its comparative advantage is? What is it?
Yeah, I mean, from the technology point of view, the way we see it is that we're going into this, what we think is a chapter 2 of EV charging, where previously it was a derivative of perhaps solar, wind, or motor drive technology, just to show that charging is possible. It could be deployed in mass scale. Now in chapter 2, these are purpose-built charger that understand the business model of charging, that understand the mission profile, the driver behavior, and so it was specific with all the knowledge and know-how that we have on how people use their cars and the type of cars that exist. These chargers incorporate the right power electronics modules that are able to scale based on the demand. So what that means is that instead of deploying, another way, EV owners would like more chargers, but then EV charging owner and operators would worry about stranded asset. So you want to have a charging station that can scale with the need. And our modularity means that we can deploy the right amount now, and when demand goes up, it can get upgraded, and there's more scalability and a better use of today's dollar.
Okay, so as we expect for more EVs to catch up, we have this whole, national electric vehicle infrastructure program where we're trying to get 500,000 charging stations across the country. We've got about 180,000 so far. We're working on the gaps, but we have gaps because the private sector has determined that there's not enough EVs to make it worth their while, right? So your point is that once we get the charging station in, we'll be able to add to it as need grows, as demand grows.
That's correct. That's the chicken and egg type of a problem that we have, and if it can scale together with demand, it makes a good use of the available dollar.
That's awesome.
So Tim, last year you had...
Wait, your mic is not on. Technology.
Hey, Tim. So last year, Fervo successfully demonstrated a well test in Northern Nevada. You just talked about also the Utah demonstration. So what's next in being able to scale your technology?
Yeah, so there's a huge scope difference between our pilot project that we drilled 3 total wells there. So 1 vertical well that we instrumented with fiber optics, and actually that was one of the things that ARPA-E supported us was advanced fiber optic technology to do the subsurface measurement on our flow characterization, and then 1 injection well and 1 production well. And so that was our first project, and it was actually a JV where we were boosting power at a existing geothermal power plant, and where there'd been dry holes drilled previously in the exact same spot that we deployed our drilling technology and brought on successful wells. So it was a great proof point for that, but it meant that the project scope was a lot different than what we're doing now. So as we go to Utah, we're now going to drill 100 wells there at this site. We've actually already finished drilling a dozen of them, and we're moving very quickly there. And in the power sector, it's all about cost. And so one thing we're very excited about is we've actually reduced our drilling costs year over year from our pilot project to our current operations in Nevada by over 70%. The first well we drilled, which was the first well ever drilled horizontal through granite at those depths and temperatures, took us 71 days. We've now reduced our drilling time to about 20 days, and we were able to scale so much more rapidly as a result of that. And then we're also building all the power plants adjacent to it. So in 2028, this will be 400 megawatts of new power that we now have fully contracted because there's huge demand right now for clean, firm power, and geothermal is ready to really meet the moment in terms of meeting that demand. And we are continuing to grow. We have about a dozen sites that look like our site in Southwest Utah that we call Project Cape. And where we sit right now with demand coming from data centers and hydrogen customers and electric vehicles and all the things that are bringing this resurgence of growth to the power sector, we're finding this is really in demand. And so we're going to break ground on another project similarly sized by next year. And then the goal is to do another project of this size, break ground on it every single year through the rest of the decade so that we can really scale this technology rapidly.
Can I jump in on this? Because I so love enhanced geothermal. And it is such a, because we're seeing such a great demand from especially the data centers, AI growth, et cetera, we project, we've been sort of flat in terms of power usage as a nation because we've been so efficient, but we're now starting to see this curve because both of electrification of transportation as well as all of these factories that are coming online because of the president's agenda and because of AI and the need for data centers. So I know that you've partnered in that regard with tech companies, but I'm just wondering if you can say a word about how you see the demand, because they're all demanding clean, firm power and clean and firm. And, they could use also small modular reactors. There's a variety of ways to get there. But geothermal and the technique that you have piloted makes it, has the benefit of being ubiquitous almost, right? So say a word about that.
Yeah, it's been fascinating to watch the space evolve. We started the company in 2017, and initially fundraising was very challenging for us actually because people didn't really see the macro trends there. The reason to do geothermal is because we need more power, we need reliable power, and we want to address climate change. And it was funny going to our first pitches back then and hearing, well, we don't really need new power because of like what you just said. There'd been flat demand for forever, and do people really care about climate? And so we found a really hard time to get traction there. And it really actually has been a lot of the leadership of the tech companies to really move this conversation forward. So, in 2018, Google did something very novel where they launched their 24/7 carbon-free energy standard, which is a much more ambitious goal. They'd previously set a goal of 100% renewable energy, which was just to, on an annual basis, average out your electricity from renewable sources. And 24/7 carbon-free energy meant that they wanted to actually power every hour of every day to come from clean sources. And it's a very different challenge. And that sort of refocused the attention on something like geothermal that has that firm attribute. And so we actually partnered with Google. They had a pivotal role in our commercial pilot. We announced our partnership with them in 2021, and they really helped us get that project up and off the ground. And what we're seeing now is that those two themes have changed a lot. Like the world has proven now in 2024 that we do care about climate, and we are going to make investments to get there. And the world has proven that, we need more energy. And that's actually a novel concept compared to where the US was for the last 20 years or so. And we need that energy to be reliable. And in particular, data centers have a demand for a reliable round-the-clock profile. And so a huge part of our business right now is being driven directly by those data center companies. And I think it's great for innovators, the people trying to move out new solutions like this in the room, that the companies that are driving forward that new demand growth oftentimes are the companies that also have the most ambitious climate targets. And I think that's a great thing for anybody trying to commercialize a new carbon-free electricity technology, whether it's a generation or storage resource or efficiency resource. because the leaders in the sector that are buying the power, that's what they want now.
It was really exciting. All of you have had really tremendous successes already. If you could just give us some insight as to what's really holding you back. Michelle, I'll start with you.
Well, I definitely would resonate with what was just said about how the world is different today than when we first started in 2019. You know, when we said, hey, we need to look at the materials that go into electrification, look at mining, look at refining. First question was, you mean Bitcoin mining? No, I mean the actual metals that go into these products. The attention on the supply chain, how we actually source and produce these materials. It's been really transformational seeing that attention being paid to how we're actually producing the raw goods that go into electrification, go into clean energy, go into storage. So the challenge moving forward, or the opportunity, mountains of opportunity, not the valley of death, that what we see ahead of us is really scaling up and meeting the growing demand. We see a lot of demand forecasted to power the next generation of electric vehicles, to power the clean energy, to power these data centers that are growing AI implementations. All of that means we need more metals, we need more critical materials. And with that growing demand, the supply's not there yet. So we need to rapidly scale our production capabilities, bring the right team, the right resources, and look across multiple industries to help us get there faster.
Absolutely, scaling is a big challenge. Ezana, how about you? What's holding you back?
I think we are in a much better position than we were perhaps a year ago. It stretched us a little bit to have a minimum viable product with and make a charger on our own. But now with the partnership with ABB, we can actually focus on our special sauce, which is making the power electronics more powerful. And these next generation chargers are actually more exciting because they're bidirectionals, and what that means is that chargers are not going to be a liability for the grid. Instead, they'll be an asset for the grid because they can provide power back, and that add resilience to the grid, which ultimately means more renewable can come online and bring energy costs further down. So I'm excited on these next generation chargers.
That's great, thank you. And Tim?
Yeah, there's still a capital gap in scaling climate technology. I'd call that the next big mountain of opportunity that we all need to address together, or bridge to bankability, or plug in your favorite term for it. There's so many terms for it because it's such a big problem. And you know what we need to see right now is, I think, well, number one, what we're seeing is a bit of a pullback in climate tech venture funding, in particular at the growth stage, and that makes it more important than ever that the DOE and ARPA-E, can step in and fill that gap to be that bridge and support at a time when the private sector is pulling back a little bit. But we also need to broaden the ecosystem of how we get tech to market. So as you go from pilot to demo to full-scale plant like we have now, you find that the people that you go to for money is completely different than before. The partners you go to build the projects is completely different before. And I think we all collectively can do a better job of engaging those EPCs even earlier in our process, because they need time to learn and get comfortable with new technology, and engaging those project debt providers earlier in the process because they need time to get comfortable with it. And I think a lot of the bridge to bankability or mountain of opportunity around this scale-up capital really does come down to building the relationships with people and letting them know that the stuff when ARPA-E funds it is crazy moonshots, but after ARPA-E funds it and you move it forward a lot of times you can de-risk that tech. And it's way more de-risked than a lot of these folks perceive. And it's our job to, I think, engage those EPCs and those project debt providers and the folks that don't have the same risk tolerance to get them comfortable earlier on. So I think we as a community of early stage innovation need to be the ones building that bridge out to that community to help us scale up.
Can I ask, I'm curious about how, so, the president has signed into law what we call the Invest in America agenda, bipartisan infrastructure law, the CHIPS and Science Act, and the Inflation Reduction Act. And as it relates to your companies, I'm wondering if you can say a word about if it has impacted you and your prospects. Maybe Michelle, we'll start with you.
Yeah, absolutely. Well, it brought attention to the biggest challenge in clean energy and technology is that exactly the infrastructure, the materials, the energy, everything it takes to actually make a full secure supply chain. We have to start at the very beginning, right? So that brought in the interest. I'm no longer telling folks we're not Bitcoin mining. We are actually talking about the raw materials, and yes, we still need that metal. It needs to be refined. It needs to be done cleanly, sustainably, and here in the U.S. So that's been able the attention that it's brought back to this sector and onshoring that manufacturing. It's made the conversations a lot easier, and it's opened up a lot of opportunities, both private and public, to allow us to grow and scale.
Yeah, and just for everybody who may not be in the weeds on this, you can't, there's a $7,500 tax credit for the purchase of an electric vehicle if it's manufactured in the United States, all of the pieces of the supply chain. So that means that we have to be able to extract responsibly, we have to be able to process responsibly, et cetera, and so in the United States. And that's why I think that the door opens for companies like yours who can really be at that front end of the supply chain on EVs, so awesome.
There's been several ways the agenda has helped our business in geothermal as a whole. I think first and foremost, there's so much more certainty around investment than there was before the IRA passed. For tax credits, we used to have to wait till the end of the year to find out if they'd be good the next year. And unfortunately for geothermal, there were many years over the last decade where wind and solar would get their tax credit extensions and geothermal wouldn't. And when you're competing in a super competitive sector like power markets and you don't know if what your financial structure is going to look like, and then your competing technologies all get a tax credit and you don't, that makes it very hard to have a consistent investment cycle. And the IRA provides such huge certainty on the tax credits and creates a level playing field where geothermal has access to the same tax credits as wind and solar do, and for an extended time horizon now. So it's actually made it much more easy for us to get investors comfortable with it. So that's a huge difference in the sector. And then the focus on demonstration funding has been a huge boost for the sector. I already gave my point on the mountain of opportunity, but one of the best ways to solve that is actually to have focused programs on demonstration funding. So what the infrastructure bill did in terms of OSED and creating the opportunity to get these first-of-a-kind projects out there has been massive. Fervo was recently the beneficiary of a $25 million EGS demos grant that we're able to apply to this first project in Utah, and that kind of help to really come down the learning curve on a new technology is vitally important to get things done. It wouldn't have been possible without the infrastructure bill.
Yeah, I think EV charging is a critical infrastructure, and I think what the new law did was brought manufacturing of EV charger in the U.S., help build the supply chains, and with the support of ARPA-E now, these are actually being designed in the U.S., and we believe that the future of grid is going to be mainly inverter based. So having the talent and the know-how to build our next infrastructure is important. So.
Great. Well, thank you for sharing that. I think we have a whole audience of innovators in this room, and you shared some great stories of how you've gotten to where you are. And can you give some words of wisdom, some advice you'd like to share with this community of innovators that aspire to really create these companies? And it's a hard path, as we've heard. Can you share those words of wisdom? Ezana.
I guess, for me, I used to think it's more about the ideas and the technology itself to succeed. And unfortunately, it has a lot to do with the finance and the bankability and cash flow. So just making sure that we consider our overall finance is going to be the key for success.
Tim.
I think the best piece of advice I can give is to keep your customer in mind and your financing strategy in mind from day one. I think a lot of engineers and scientists and innovators get used to a rhythm of the purpose of research is to make something a little bit better this year than it was last year. And moving into a startup phase, you have to really think differently about commercialization and technology. And the goal isn't to make the tech a little bit better this year than it was last year. The goal is to make sure that the tech is meeting a customer need, because that's how you get that product out there. And I think that's a big shift a lot of times. I had to go through that shift. We were very fortunate to be part of the Activate program at Lawrence Berkeley National Lab, and they did a great job of drilling this concept into us early on, because I just wanted to be a little bit better at drilling each time and figure out this thing, and they really pushed us to think about, well, actually, how do you make this tech work in a customer framework? And we developed things way differently because of that focus on commercialization. So it's never too early to think about the end use in your customer and really get out there and interview them.
Thank you. Chao?
I'd say no one brilliant does it alone. You need a whole team behind you. So I would encourage folks to early on Don't try to do everything by yourself. Find the right partners. Hire the right team. Make sure that you're not doing everything by yourself. It takes it takes investors. It takes government support. It takes brilliant scientists, engineers, finance, customers. It takes a whole team to come together to really make the transformative changes we're trying to do. If we're going to achieve that net zero emissions in 2050, we all need to come together and work together to achieve that common goal. So my big advice is don't try to do it by yourself. Reach out, talk to people. This is an amazing group of folks here, even in this room. So my biggest advice is, hey, it's a team effort. Let's do it together.
Awesome, awesome. Well, can we give a big round of applause for these incredible entrepreneurs? Thanks, you guys.